Questions? All right, if you've got a lot of noise, you would use that just dissonant noises. I think the word cacophony is probably the appropriate one to use. If you've got a whole bunch of disparate smells, is there a word for that? A cacophony of smells? What would be the collective noun? Okay, you have to come up with something?
An abundance or something?
So abundance makes it sound like, yeah, I was looking for something that sort of implied smells that don't go together. You know, like banana and anything. I don't have anything against bananas. It's just, I was smelling raw tobacco earlier. Which in and of itself is not a horrible smell unless you're overwhelmed by it. I don't know if you've ever been to Durham. You catch it on the right day, walking by the wrong place, smell it on your clothes for hours. The nodding Briley made it seem like you've gone through that, done the Durham tobacco experience. All right, so what's going to happen here is I'm going to trigger it. So I'm going to have a ball here, and then there's going to be a ball on the other side. Flip that around. So there'll be a ball here and a ball here. Assuming that's level, I'm going to flip the switch, and there's a spring inside here which is going to take this rod and shove it that way. Now, the ball that's here is going to get projected out, and the ball that's here, because the friction is low enough and time is very small, when this rod goes shooting that way, this ball should fall pretty much straight down. And so one that's projected and one that's launched. That is the same size, right? Yeah. And the question is, which will hit the ground first? I will move it so it doesn't hit the table. So they both actually hit the carpet, is the plan at least. Assuming they both hit the carpet without hitting anything in between. All right, physics by democracy. So we have the one that falls, the one that's projected. I guess then there's tie and neither. All right, have an opinion. Even if it's just, you flip the coin in your hand. Who says this one will hit first? Who says this will hit first? Tie? And I think that's everybody. Anyone would go for either, that they burst into flames on the way down? All right, so since the majority of people thought this one, someone want to explain why you're saying that?
Because that one should just go straight down, the other one's gonna go out and down.
Okay, so it says farther to go.
Yeah.
Anyone had a different justification? And Sushil, why'd you say a tie?
Because that's like usually what happens with if they're the same weight, then
They're not the same. gonna change your answer?
No, I think it still fall at like the same speed or the same rate, so that's why.
Okay. And Cassandra,
Yeah.
what do you think? Which one of these?
What are we talking about?
You had a chance to be brilliant. Just come in, throw out the right answer without, it's like playing around in hand and poker without ever looking at your cards.
It's going down straight.
The question, when those two get shot at the same time, the one that falls and the one that gets projected outwards, which one's gonna hit the ground first? That's the question. Now, you're not knowing the question, you went with this one.
False. They're both gonna hit the ground at the same time.
You vote? Why? Or what is your reasoning? Or is it just a flip of a coin in your head?
No, because when we spoke of, like, this is reverting back to like our earlier chapters, I think we were talking about like if a ball drops, regardless of its mass, like if they're both like go at the same time, which is gonna hit the ground first, and then both hit the ground.
Okay, so the fact that it's being shot that way does not affect.
It could.
Do you want to change your answer or stick with it?
I'm gonna stick with it.
Okay. Place your bets. Now you might have to listen for it because this one's going to get somewhere over here, so they'll be able to see it at least. And is that level? Okay, here we go. Congratulations. The most common thought here, and the reasoning is usually the reason that I'm given. The difference is this does go farther, absolutely, but it's also traveling faster. But going with what Sushil was saying, once they're in the air, what is the force acting on? I'm going to nitpick at this point.
Wait.
There we go. Or force due to gravity. They're both being pulled down. So it is like you're just dropping the both of them. The horizontal velocity here doesn't change actually. The horizontal, so if at any point on the path here, so if this thing gets shot out, it's going to do like that. It starts out with the entire velocity is horizontal. At this point right here, the horizontal velocity is the exact same as it was before, but now there's a vertical component. At this point right here, the horizontal velocity is still the same, it's just a longer vertical component. All that's changing is the vertical part of velocity. So, given that, how fast was this ball shot? Well, I know they hit the ground at the same time. So let's figure out how long it took that to hit the ground. I happen to have a meter stick here. And it's above a meter. Is there a second meter stick? Oh, back there. And it looks like all of that was off video. Okay. All right, so it's going to fall. Measure to the bottom of the ball. So it looks like, let's get it. $135 centimeters. All right, so this is going to fall 135 centimeters, or 1.35 meters. How long is it going to take that ball to fall? 1.35 meters. Or how would you go about finding it? There's a nice little formula. If you happen to have your first test, that first page. Cassandra, you look like you want to say the right answer.
Is it the average speed times time? Or is it
We don't know the final speed, so average speed would be difficult here.
So distance over time.
This is what?
Distance over time?
There should be another formula specific to objects falling, starting at rest. Or I'm imagining things, which is also possible.
1/2 GT squared.
Oh, that's the, yeah, it's that one that she just said. The most recent test, I thought I had it on it. That's an old one. That one. All right, so the distance falling is going to be 1/2 GT squared. I know the distance, I know G. It's just a matter of solving for time. So the math problem we're working with here is 1.35 is equal to 1/2 times, for what we're doing here, 9.8 is fine, times time squared. So how do we solve for time? What's first?
Multiply 9.8 by 1/2.
Okay. So 1.35 is equal to 4.9 t squared. Now what?
Divide by 4.9 on both sides.
So as we first have to isolate t squared and then get to t, so we divide by 4.9, so t squared is equal to whatever that is. Someone's about to tell me.
0.2653.
Like 2653. And not that we are at the end, so we don't have to put in units at this point, but just out of curiosity or just what the heck, why not? What are the units of this 0.2653?
Seconds.
If you're stopping there, no. Think about what you're trying to find, or think about what that is.
Meters per second?
No. It's not a unit that we usually work with. I mean, it does involve seconds, but it's... What is T?
Time
Yes?
squared. Second squared.
Yes, second squared. Because it's a time, time will be in seconds here, but because it's squared, that would be second squared.
Do we not have to square root it?
We do. That was just a small little diversion by the side of the root, a scenic view. And so the time it is in the air is
0.5150
0.5150.
seconds.
All right. So we now know how long this other one is going to be in the air. So to figure out how fast it's going when it gets launched, well, all we have to do is see how far it goes horizontally. Because I know the horizontal part isn't changing. The acceleration is downwards. So the horizontal piece will stay the same. So however fast it's going when it comes off of this, again, that horizontal piece will stay the same. So I just have to figure out how far does it go horizontally, and I can figure out the speed. So we have to launch it and figure out how far it goes. So let's see, if we take a point just below this, I think it's going to hit the middle. Yep. So we're going to eyeball this. There are, of course, better methods. Now, a better method to figure out how far it goes is to put down aluminum foil or something like that instead of, we're going to just spot it by eye, but if we had aluminum foil down, it's going to hit the aluminum foil, and we'll see exactly where it first touches the ground. All right, so I'm going to rely on, I guess, U4 will probably have the best point of view. It was somewhere around here, I think.
Yeah.
A little bit. Right there. So 134. Okay. The rest of you in agreement? All right. So it went 134 centimeters. Just coincidence. It's so close to that one. So horizontally, it went 1.34 meters. And so that is the horizontal distance. I know how long it's in the air, so how do I figure out how fast it was going?
Acceleration is, we have to find acceleration.
Yeah.
Right?
Okay, what's the equation?
Change of velocity over change of time.
That's acceleration. It's something similar to that. Acceleration is changing velocity over change in time. So velocity. Other people can help her out. Or you just enjoy watching her squirm. Pardon? Sorry?
Displacement over change of time.
Yeah, that's it. Change in position over change in time. That would be average velocity, but since the horizontal piece doesn't change, that velocity works. So it went 1.34 meters in 0.5150 seconds. So it is being ejected at a whopping
2.60.
2.60?
Meters per second?
Meters per second. Like 5.5 miles an hour. So we now know how fast it's going. We could do one other thing. How far can we shoot that thing up in the air? Well, let's calculate it, and then we'll see how close we get. So if this thing gets launched at, we will assume 2.6 meters per second, how high up will it go before it stops? And we can actually solve this using energy, chapter 3 equations, or momentum. Whichever one feels right. Anyone with a preference? Which one?
Momentum.
Momentum?
Yeah.
You had to pick that one. Okay. All we're doing is looking at the ball, so therefore it is an open system. There's a force acting on it, on the ball, from outside the ball. I'm not looking at the ball earth system, just the ball. So it's a open system, so therefore the impulse is equal to the change in momentum delta P. Impulse, what's the other equation for besides change in momentum for impulse? Jennifer, it looks like you want to say something.
Is it the mass times velocity?
That would just be regular momentum. We'll put that in a note, we'll use that in a moment. There's two ways of finding impulse. One is finding a change in momentum, the other one is, well, the other one that we're trying to do. It involves force, if that's any help.
Force equals change in time.
Say it again?
Force times change in time.
Yep. So we would need to know how much time it's in the air when it's being shot upwards. That this momentum actually is the hardest of the three choices there, but we can still do it. Well, let's figure out how much time it's in the air. I have something going 2.6 meters per second all the way up. I know acceleration, as identified earlier. It's change in velocity over change in time. Therefore, well, what's the acceleration going to be as it's going up?